Hello friends, welcome to engineering tutorial. So this is the fifth question related to application of Thevenin theorem to circuits involving dependent sources that we are going to discuss. So we have the circuit here which consists of a dependent source which is a current dependent voltage source, because it is a voltage source but its value is dependent on this current flowing through this 12 ohm resistor. Okay, and there are no independent sources present in this circuit. Okay, and we have been asked to find VTH and RTH. So like we have did in all the circuits in which there were no independent sources present, VTH in this circuit is equal to 0 volt. Thevenin voltage is 0. Why? Because no independent sources are present, voltage or current, nothing is present, so VTH is equal to 0 volt. So now all we have to do is find RTH. So RTH we can calculate by exciting the circuit by connecting either a 1 volt voltage source or a 1 ampere current source. So let us connect a 1 ampere current source here and apply nodal analysis to find this terminal voltage across the 1 ampere independent current source, the exciting source. RTH will be equal to V0, the terminal voltage, by 1 ampere. It's in volts. Okay, this is the important equation 1. Next important thing is to establish a relationship between this current dependent voltage source and the parameter on which it is dependent. So if we connect a ground here, voltage, terminal voltage here is V0, so here also it will be V0. Why? Because there are no resistors in between, so no voltage drop, the voltage here will also be V0. The value of I, the current I is flowing downwards, so I will be equal to higher potential minus lower potential, that is ground, by resistance involved, which is 12 ohm. This much, or we can simply say it is V0 by 12. V0 by 12. This is an important relationship. So now let us write the nodal equations. Here let's say this current is flowing towards the node, whatever current it is flowing towards the node. I is flowing outward, 1 ampere is flowing towards. So all the towards flowing current are on one side, so 2I minus V0, 2I is a voltage source, that's why 2I minus V0 by 6 plus 1 is also flowing towards the node, is equal to, this is the outward flowing current I. So I have already made a video related to nodal analysis and some questions related to it, so please watch those videos first, okay, so that you understand this in a better way. Here I am just going directly. Now let us substitute the value of I in terms of V0. So it is, that implies 2I, which is V0 by 12 minus V0 by 6 plus 1 is equal to V0 by 12. So this is 6 V0 by 6, so that implies, let us write it down here, that implies V0 by 6 minus V0 plus 1 is equal to V0 by 12, or we can write it as V0 by 36 minus V0 by 6, this one. If we take minus V0, this towards this side it will become minus V0 by 12, and 1 on the right hand side will become minus 1. Now taking LCM as 36, the V0 minus 6V0 minus 3V0 is equal to minus 1. So let us erase some portions here. Okay, we have solved this, so because of lack of space I have to erase it again. You can rewind and watch it again where you cannot follow. Okay, so this one, it will be minus 8V0 is equal to minus 36. That implies V0 is equal to minus 36 by minus 8, which is equal to 9 by 2, which is equal to 4.5 volt. V0 is 4.5 volt, we calculated. RTH is V0 by 1 ampere. So RTH here will be 4.5 volt by 1 ampere, which is this exciting current source which we connected to the circuit. V0, the terminal voltage, is 4.1 volt, so it is 4.5 ohm. The RTH here is 4.5 ohm. Okay, we calculated, sorry, 4.5 ohm. So no VTH, VTH is 0 volt, as there is no independent sources present in this circuit, only RTH was there to calculate. So we connected a 1 ampere current source, exciting current source. We calculated the terminal voltage V0 by applying nodal analysis. We got V0 as 4.5 volt. Then we used this simple equation to find out RTH, which is 4.5 ohm. Okay, so this is the fifth question related to Thevenin theorem application to circuits involving dependent sources. Okay.